Hello my dear students, welcome back to NEET World. So in the last session we have discussed about mole concept and its interconversions and also what is the application of mole concept during a chemical reaction. So all these things were discussed and I have given few questions as a homework. I hope everyone watched those sessions carefully and you have solved those questions right now. Yeah. So today we will be discussing something more related to periodic table. So now if you are studying anything related to chemistry means you must know the elements that we discuss in the chemistry part right now. So there are around 118 elements presently in the periodic table. Okay, so now we need to know about these 118 elements and how they have got classified and what are the struggles they did to classify all these elements. We need to have some clarity on this. Okay, so before coming to this final periodic table, this is what a modern periodic table. There were many other attempts given by different scientists to get a proper arrangement of elements in the periodic table. Okay, now the first and well known classification here is Daubernier triads. What is that? Daubernier triads. So what he told triad, what is that? A triad. So as the name itself indicates that he has taken the elements in the form of triads. Triad means what? Triad, I am saying triad. So it means set of 3 elements. What is this? Triad means 3 adds. Here you can say set of 3 elements. Okay, what he considered? Set of 3 elements. Whatever the known elements are there at that time, he taken set of 3 elements. Okay, now he observed, let us say elements A, B, C are the 3 elements he taken and he arranged them in the increasing order like this. Okay, increasing order of their atomic weights. Okay, now I am saying atomic weight of A, atomic weight of B, atomic weight of C, like this he made the elements in the increasing order of their atomic weights. Now what he considered is, what he got here is the atomic weight of middle element. After arranging the elements in the increasing order of their atomic weights, the atomic weight of middle element, what is our middle element here? B is equals to atomic weight of A plus atomic weight of C. It means what he considered is the average atomic weights of first and third element will be equals to the middle element, that is the second element. So this is how he arranged the elements in the form of triads. Okay, now what are the best examples here? We have LINAC, like lithium, sodium, potassium. You can remember like this. Now the atomic weight of first element and this last element average gives you this middle element, that is sodium atomic weight they will give you upon doing average. Okay, like this he has calculated the atomic weights of the middle element using first and third element and he arranged the elements. Okay, and chlorine, bromine, iodine, this is also second set of triad. Like this he has given some triads. It means when he classifying the elements based on the triads, he has able to give this set of triads only to few elements, not for all the elements known at that time. It means he is able to classify only few elements, not all the known elements. Therefore the triad concept got failed because he is not explaining about all the elements present, he just explaining about few elements. Therefore this Daubernier triad got failed. Okay, and after him we have other scientists who came up with some other approaches. So the next one is Newland's law of octave. What is that? Newland's law of octave. So what is this Newland's law of octaves? I am saying octave means we know in the musical notes we have 8 notes. What are the 8 musical notes we have? Something like sa re ga ma pa da ni, again sa. It means the first element and the last element, that is start with sa, and also again at the 8th again you are going to see something like sa re ga ma pa da ni sa. Again like that you are going to see sa and sa. It means every first element repeats at the 8th element. In the same way, he has arranged the elements, the known elements at that time, something like lithium, next beryllium, boron, carbon, nitrogen, oxygen, oxygen, fluorine. Okay, noble gases were not known at that time. Then next what we have, fluorine, neon, because noble gas is not there at that time, means what will get, sodium. Like this he has arranged all the known elements. Okay, okay, so now here 1 2 3 4 5 6 7 8. Okay, after sodium what we have, magnesium, aluminium. Okay, like that you keep on arrange up to calcium. Okay, how can we arrange them? Based on their increasing atomic weights. Okay, so like this you need to arrange based on the increasing atomic weights. Now what he observed is, for every first element and the eighth element, like here it is sodium, so they have repetition in the properties, similarities in the properties. Okay, now tell me what is a set, that is law of, Newland's law of octave, that get a pair along with this beryllium that is having similar properties as like beryllium in the given arrangement. Yeah, see, if this beryllium is considered as 1, this is 1 means 1 2 3 4 5 6 7 8, means beryllium and magnesium. Like that you can expect direct questions also in the exam. So now what are the elements having similarities in the properties as per the Newland's law of octaves? Okay, so now Newland's law of octaves says what, every first element and eighth element are having similarities in their properties. Okay, now we need to arrange the elements in the increasing order of their atomic weights in Daubernier as well as in Newland's law. ఓకే, ఇలా అరేంజ్ చేసిన తర్వాత అటామిక్ వెయిట్స్ ఇంక్రీజింగ్ ఆర్డర్లో అరేంజ్ చేసిన తర్వాత ఫస్ట్ ఎలిమెంట్కి ఎయిత్ ఎలిమెంట్కి ప్రాపర్టీస్ అనేవి సేమ్ ఉంటాయి. ఓకే, సో అలా న్యూలాన్స్ లా ఆఫ్ ఆక్టేవ్ అనేది వీ హ్యావ్. ఓకే, like that for boron we have aluminium, like this. Okay, just remember. Now the limitation comes here is, దీని యొక్క డ్రాబ్యాక్ ఏంది అని అంటే, సో this whatever the discussion is there, that is only applicable for lower elements. Lower elements means lighter elements. Lighter elements means with less molecular weight, atomic weights. So it means it is applicable only up to 40 atomic mass units. It means only up to calcium it is like agreeing, but not for other elements known at that time. Therefore this is also having limited set of arrangement now, therefore this is also got failed. Okay, like this we have other let me check anything is there in this. Like this we have the second one also, like Newland's law of octave also, but this is also got failed. So after this we have Luther-Meyer curves. Okay, so Luther-Meyer curves we have. Next Mendeleev periodic table we have. So what Mendeleev did is, he arranged the elements, all the elements with increasing of atomic weights. Okay, what he arranged, he taken all the elements known, around 60 elements at that time, and he arranged them in the increasing order of their atomic weights. Okay, and he found there is some similarities in the properties. Okay, in few set of elements, when he arranged the elements in the increasing order of atomic weights, he found some similarities. Okay, and you know, Mendeleev given his periodic table with some predictions, what he predicted is, he just left some space for some elements that were not known, and later after few years that elements got discovered and they are exactly fitting into the space that is predicted by the Mendeleev. Okay, like that what are the predictions he did? He did predictions for gallium. For what? Gallium. Okay, so gallium, and see, he told that gallium, in the place of gallium he just mentioned it as Ika boron. What he mentioned, the space he mentioned it as Ika boron. It means Ika boron means there is an element fits into this position, that element let us call it as Ika boron. So later they got some elements which are exactly fitting there, like that Ika boron, Ika aluminium, okay, Ika germanium, germanium. Like this, he given some spaces, empty spaces with predictions. So now what do we mean by aluminium? This is gallium. What is it? Aluminium means gallium. Next, silicon. Silicon means germanium. Like that, for these elements, at that time it was not discovered, but he predicted in future we are going to discover some elements like gallium and germanium. Let us mention them as aluminium and silicon in the table. Like that, he given some prediction positions for the unknown elements also. Okay, when it comes to boron, there we have scandium. Okay, what we have? Scandium. Presently we have scandium. Like that, he given some empty spaces also. Okay, but after understanding all these things, the next periodic table here and the mostly accepted and now currently we are using is Henry's Moseley's periodic table. What is this? Henry's Moseley's periodic table. So how he arranged the elements? He arranged the elements in the increasing order of atomic numbers. What he considered? He considered atomic numbers. Okay, and he arranged the elements like atomic number 1, 2, 3, 4, like that he arranged. Previously, whatever the atoms we have seen, all of them are arranged with the increasing order of atomic weights, but here it is based on atomic numbers. Okay, now how he got to know that atomic number? Yeah, so what he did is he taken elements and he taken X-ray spectra. What he taken? X-ray spectra of these elements. That applied frequency will be there now. So with that applied frequency, how these numbers are changing, how that nuclear charges are changing, all these things he observed. Therefore, he arranged the elements in this set of table. Okay. Now what he found is the periodicity in the properties are not because of their atomic weights, but it is because of their atomic numbers. Okay. So what is the periodicity here? You need to consider this as atomic number, not as atomic mass. Okay. So this is the important thing you need to remember. Okay, right. So when he is giving this table, so he mentioned that the first two things here we are seeing, these vertical lines are called groups. What we can call groups. Like that, how many groups we have? 18 groups we have, because if you count vertical lines like this, there are 18 vertical lines. Therefore, you can say all these vertical lines as groups. So therefore, how many groups are there in the periodic table? 18 groups are there. How many groups? 18 groups are there. Okay. Now, the first two groups are there. Now, these are called S block elements. What they are? S block elements. Okay. Then next here, from boron to helium, this side you are seeing now. So this is called P block. What is this block? P block. Okay. So this middle one is there now here, from here to here. So this is called D block. Okay. D block. And this bottom portion are there now, this two series, two rows you are seeing. So remember, in chemistry we are using these words, vertical lines like this, we are saying this as groups. What we are saying this as? Groups. Okay. And we are writing something like this. It means these horizontal lines are there now, these are called rows. Okay, remember these lines. Okay, so groups and rows. If you observe how many groups are there, 18 groups are there in the periodic table. And if you observe like this, how many rows are there, like horizontal lines, how many are there? So 1, 2, 3, 4, 5, 6, 7. So how many rows are there? 7 rows are there. Therefore, these rows are called periods. What they call? Periods. So how many periods are there? No, 7 periods are there. Sir, you are only counting this, why not this 2? You should say it as 9 now. Why you are saying only 7? Because all these series elements will be lies here in the lanthanum. 57 is there now. At that position only all these elements will be lying. Okay, and all these elements were located exactly at this actinum position. But if we place all elements there, the periodic table looks very, very clumsy and it is most unsymmetric right now. So that is the reason they just mentioned them in the bottom of the table. Okay, but what you need to understand, yeah, all these 2 rows elements lies at these positions only. Okay, like same color is there now, so in that same color you fix them. That's it. Okay, now this is first group, second group, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, like that you can mention the group numbers. Okay, now tell me, all lanthanides, actinides belongs to which group elements? They are third group elements. Which group? Third group elements. Remember this. Okay, and they will also ask which period elements they are. Which period elements? See, lanthanides are belongs to this now. So you can number now here 1, 2, 3, 4, 5, 6, 7. So all lanthanides belongs to which period? 6th period. Okay. Similarly, all actinides belongs to 7th period. Like this, we can make the questions or we can understand the concept. Okay. So all lanthanides belongs to which period? 6th period. And which group? Third group. All actinides belongs to which period? 7th period. And which group? Third group. Like that you can remember. Okay, right. So in the last class, in the last previous sessions, I have given writing the electronic configuration for the first 30 elements, if you remember. Okay, so if you are not aware of writing electronic configuration, please watch those previous session so that you will get some clarity. Okay, right. Let's move forward. Okay, and let us understand here itself some properties also. Now, why they arranged all the elements in this periodic table? What is the need of arrangement? Yeah, they arranged the elements to make studying the elements and their properties easier. To make it easy to study the properties of elements and their chemical reactions. So, for example, here, if you observe the elements which are at the left side of the table, okay, consider this is left, right, okay. So, if you observe the elements which are at the left side of the table, okay, ignore this hydrogen, other than hydrogen we have now, all these are elements are metals. What they are? Metals. What they are? Metals, okay. And in the complete periodic table, these first row elements are there, like first period, like first group elements are there now. So these are called alkali metals. What they are? Alkali metals. Why they are called as alkali metals? Because these metals, when they react with water or any other substances, especially water, they forms hydroxide, like bases. Bases are called alkalis. So alkali metals. So these are also forms bases, and they exist in the earth crust as oxides. So now what we can call these group elements as alkaline earth metals. What I am saying, these are alkali metals, these are alkaline earth metals, okay, because they appears as oxides, which oxides are also basic in nature, that is appears in the earth crust. So these are alkaline earth metals, these are alkali metals. Okay, next come this side. So these are called p block elements now. So you can say this as boron family, carbon family. Okay, these are nitrogen family, simply are 15th group elements. Okay, this is 13, 14, 15, 16, 17, 18. Okay, now all these fluorine family elements are there now. Those are called halogens. What they are? Halogens. And these 18th group elements are called noble gases. What they are? Noble gases. Okay, and when it comes to 16th group elements, these are called chalcogens. What they are? Chalcogens. Okay, and the next one here this 15th group are there now, nicogens. Okay, so why we are calling them as nicogens? Because the compounds, the hydrates of these 15th group elements are poisonous gases. What they are? Poisonous gases. That's why we are calling them as nicogens, 15th group elements. Like this, you can understand the elements. So what I told you, these elements are metals. Why these elements? How we are saying they are metals? Yeah, whenever they are combining with some other elements, whenever they are combining with some other thing, they are existing in the positive nature. These elements are existing or converting into a positive form. So metals are electropositive. More electropositive nature, more is a metallic character. Okay, so these S block elements are what? You can simply understand them as metals. Okay, whereas if we move from here to here like this, so this side it is becoming, all these elements we have discussed now, so those are behaving with lower metallic nature. It means they are becoming from metallic nature to they are becoming non-metallic nature. So what they are becoming? Non-metallic. So in non-metallic I can say two types. So these are metals I am saying now. So as I move from these metals to like this, so you are going to see some set of elements like this. So these are called metalloids. What they are? Metalloids. And the remaining elements, whatever you are seeing this side, are called non-metals. What they are? Non-metals. Okay. So this set of elements like little brown color we are seeing in the table now. So those are what? Metalloids. It means metalloids are having intermediate properties between metals as well as non-metals. Okay. So as we move from left side to right side of the periodic table, what happens? Metallic nature decreases, non-metallic nature increases. So left side of the table we have metals. As we move right side of the table we have non-metals. Okay. Remember in that form. Okay. So metals, metalloids, non-metals. Okay. Remember like this. And one more term I used. How can we say the metallic nature? So if an element losing the electron easily, it means that element wanted to stay in the positive form. That is what? Electropositive nature. If the element wanted to be in the positive form, electropositive nature, you can say it has more metallic nature. Okay. So these elements are metallic in nature because they are electropositive. Okay. They have more tendency to lose the electron. Whenever they combine with anything in any chemical reaction, they want it to be in the positive form only. For example, you are taking a sodium metal and you are throwing it in the water. So suddenly what happens, so this sodium atom becomes sodium ion like Na plus. Okay, and OH minus from water becomes NaOH. Okay, even when you treat sodium with any other thing, like let us say it is exposing to oxygen, what happens? Again sodium converts into Na plus form. So you take any of these elements here which I have mentioned, all these elements, whenever they are combining with other things, they wanted to be in unipositive charges like Na plus, Li plus, Ka plus, Rb plus, like that. Okay. Now the down the group, if we move down the group, what I am saying, if we move down the group like this, the ability to lose the electron is very much. It means as we move down the group, the ability to lose the electron is more. It means that electron comes out easily. So electron coming out easily means I can say metallic nature down the group, metallic nature increases. What happens? Metallic nature increases down the group. So in the periodic table, as we move down the group, metals will be at the bottom. Okay. So down the group metallic nature increases. You can remember like that. Okay. So as we move up from top to bottom, metallic nature increases. Okay. And when it comes to this side, down the group, here also metallic nature increases. So it means the elements which are at the top of the table are mostly non-metals and they are more electronegative. Bottom elements I am saying more electropositive or more metallic in nature. Okay. If bottom elements are positive nature, top elements should be negative nature. It means electronegative. So these are electropositive, these are electronegative. So what you can say? Electronegative. Okay. So simply you can remember metals are electropositive, non-metals are electronegative. So what do we mean by electronegativity or electronegative? I will tell you, just listen to me here. Okay. So if before giving you this, there is a bond, let us say A, B are the two elements. Okay. So what I am explaining now? Electronegativity. Okay. What do we mean by electronegativity? The tendency to attract the bonded electrons towards one of the bonded atom. Okay. Let us say this bond contains two electrons now. Now let us say element B is having more tendency to drag these bonded electrons towards itself. Therefore, I can say electronegativity of B is greater than electronegativity of A. Okay, so what do we mean by electronegativity? The tendency to attract the bonded pair electrons towards itself is called electronegativity. Okay, so like this you need to check only in the bonds, not in the normal cases. Okay, so like this, if you observe, I have complete table here. So in this complete table, if you observe with the electronegativity values, which element is having highest electronegative value? See, the fluorine is the highest electronegative element in the table. So in complete periodic table, who is more electronegative element? Fluorine. Okay, remember the highest electronegative element in the periodic table is fluorine. Okay, and after that, if you move from this side also, see what is happening as we move from here to here like this. What is happening? You check the element which is at the right side of the table is having more electronegativity, like 4.0. So here it is 3.5 only, here it is 3.0, 2.5, 2.0, here it is 1.5, 1.0, hydrogen 2.1. Like this, if you see what is happening as we move from left to right, electronegativity increases. So these elements are having more electronegativity, fluorine, and the second most electronegative element is oxygen, and the third most electronegative element is nitrogen as well as chlorine. So it is observed that nitrogen and chlorine is having almost same electronegativity values, like nitrogen here, chlorine here, remember this. Okay, so now if you clearly observe, so you can conclude two important points. So electronegativity, En means, let us say electronegativity decreases or increases, let us write, increases from left to right, from left to right, from here to here. What is happening? Electronegativity is increasing. Okay, now one more term also you can write, one more statement, electronegativity decreases from top to bottom, top to bottom. Why? Once check here, so it is 4.0, 3.0, 2.8, 2.5, 2.2. So what is happening as we move down the group? Electronegativity values are getting decreased. Okay, so you can make these two statements in your notes. Okay, electronegativity as we move from left to right increases, top to bottom decreases. Okay, now the bottom elements are having more, relatively more metallic character when compared with the top elements. Okay, in any of the group. Okay, so like take a screenshot of this and try to remember few like electronegativity values like fluorine, oxygen, nitrogen, because these elements we will be using in our most of the times, in most of our classes we will be coming across these elements. So try to remember their electronegativity values also. For carbon 2.5, hydrogen 2.1, nitrogen 3.0, like this. Okay, now one more thing, if you observe, most electronegative element in the periodic table, what is that? I told you, fluorine. Okay, and more electropositive, what I told you, down the group electronegativity decreases and electropositivity increases. Like electronegativity, positivity, these are like opposite statements now. So that's what I am saying. Electronegativity decreases down the group, it means electropositivity increases. So more electropositive, it has more metallic character. So if you go down the group like this, what happens? Metallic nature increases. So most highest electropositive element in the periodic table is cesium. Cesium is highest electropositive element in the periodic table, and highest electronegative element is fluorine. You can remember like this. Okay. Now remember, when a less electronegative and more electronegative elements combines will get a ionic compound, more ionic character containing compound. Okay, so what is the best example of ionic compound that we can make here with maximum ionic nature? Cesium using more electropositive element. This is cesium ion and fluorine ion, that is cesium fluoride. Which is that compound we can prepare ionic compound here? Cesium fluoride. Okay, which is having more ionic character here. I hope it is clear how we have made this. Okay. Now from this you need to get one understanding here. If electronegativity difference is more between combining atoms, or elements, then compound is ionic. What I am saying, compound has ionic character. Okay, and the next statement, if electronegativity difference is intermediate between the combining atoms, then the compound may be amphoteric or maybe sometimes neutral also. Okay, right. Next, one more thing here. If electronegativity difference is less or almost equal between the combining atoms, then the compound is covalent. Let us understand this by taking some example. 3 statements which are generalized statements useful for understanding the concept. Okay, see what I am writing here. Which is most electronegative element we have seen? Fluorine. What we have seen? Fluorine. The next oxygen, the next nitrogen, here chlorine. Like this we have seen. Electropositive elements here we have seen like nitrogen, here carbon. This side sodium, potassium, rubidium, cesium, here calcium, magnesium. All these elements we have seen like this. Okay, now remember which is most electronegative element here? Fluorine, right now. So when fluorine is combining with any of these elements, see these are electropositive or not, alkali metals, S block elements, no? So the compound will be ionic. What type of compound it will be? So when these halogens are combining with these elements, there will be large electronegativity difference. For example, cesium I told you, fluorine I told you. There is a huge electronegativity difference. Here it is a 4.0, this is just 0.7. So almost 3.3 electronegativity difference is there. So more is the electronegativity difference, the compound has more ionic character. Okay, that's why the first statement I have made in a generalized format. Okay, now when it comes to a carbon having electronegativity as around 2.5 and here oxygen having electronegativity around 3.5, right now 3.5 because fluorine is 4.0. So here the electronegativity difference between carbon and oxygen is not much. So it is around how much? 3.5 minus 2.5. This is just 1.0 electronegativity. So the compound will be mostly neutral or amphoteric. Here carbon monoxide is neutral, you can remember. Okay, neutral oxide you can remember. Okay, and one more thing here I am saying, if the electronegativity difference is less or equal, see, and I told this as neutral compound, no, not only neutral, but you can also say whether it has the bond nature as covalent or ionic also. See, so the bond nature, if the electronegativity difference is very less, the bond nature will be covalent, more covalent character it has. What character it has? More covalent. If electronegativity difference is maximum, then you can say it as ionic character. Okay, the nature of bond you can say, the nature of oxide also you can say. Okay, so these are the 2 things to be understood here. Okay, so now I will be asking you to answer this question as per the discussion. Arrange the following elements in the increasing order of electronegativity as per the discussion. Tell me which is most electronegative element we have seen? Fluorine. After fluorine, oxygen. Then next nitrogen. Then next carbon, silicon. So second option is our perfect answer for the discussion, right? Yeah. So guys, if this is clear, please hit on the like button so that I can consider you are following the session. Yeah. Next, let us move forward. Yeah. So whatever the story we discussed about this electronegativity differences and all, everything is mentioned here. Check once. So what I have given you, if the electronegativity difference is huge, if the electronegativity difference is more than 2.3, the compound formed will be basic compound. Which compound? Basic compound. And the compound has ionic nature, I told you, no? So that will be having basic character if that forms an oxide. Okay, it means how that oxides are formed. When an oxygen is combining with a metal or the other elements, the compound formed generally considered as oxides. Okay, in oxides, oxygen should be with -2 charge. With what charge? Oxidation state should be -2. Then the metal should be with positive charges. Okay, now for example, sodium oxide is formed. Okay, carbon dioxide or carbon monoxide is formed. See, there will be, this is a metal, this is a non-metal, so the compound formed will be having more electronegativity difference, which is greater than 2.3 almost. Therefore, this oxide is basic oxide. Whereas here carbon and oxygen is combined, here we have seen electronegativity difference just as 1.0. So 1.0 means less than the this 2.3 now. So what I told you, it is very less now. Either it can be neutral or amphoteric, I told you. Here if I write carbon dioxide, here this is acidic. What is this? This is acidic. This is acidic because electronegativity difference is further less here. Why further less? I will tell you. Okay. So just remember here. So these elements forms like oxides as basic oxides. Okay. And this side elements like fluorine, this side elements forms acidic oxides, and this middle elements, if you see, especially this one, boron and aluminum, here we are seeing now. So this forms amphoteric oxide. Al2O3 is the best example of amphoteric oxide. Okay, remember this. So why I am giving you like this means these are the generalized understanding of concept. Okay, when it comes to each example to example, we will do them in our regular classes, but this is a bridge course now. So I want you to give some basic understanding of the concept that we are going to deal in upcoming sessions. Okay, right. Let's move forward. Yeah. So isoelectronic species, we will discuss about this. Now look at this. We were discussing about sizes also. In the periodic table, what happens if you take any elements, like what are the first group elements we have, tell me. So like lithium, sodium, potassium, rubidium, cesium, like this we have now. So now what happens to their sizes, tell me. So this is having electronic configuration as 1s2, 2s1. Okay, this is 3s1, this is 4s1, 5s1. Like this if you observe 6s1, like this we have general electronic configuration. So these coefficients, if you observe, these are called principal quantum number. Okay, so what these principal quantum numbers indicates is, if this is the nucleus, then the circular paths that you are seeing now, so these are called shells. So this shell numbers only here we are indicating. This is n equals to 1, n equals to 2, n equals to 3. So now what you are understanding from these, so as we move down the group in the periodic table, the size of the atom is also getting increased, the size of the element is also getting increased. It means the one which is at the down at the bottom of the periodic table having greater size. So what is the order of the atomic radius or atomic size? Atomic radius increases down the group. What happens? Down the group, increases down the group. Now tell me, what are the size order for these elements, these the elements that I have mentioned here. So lithium should be smaller, the next sodium, the next potassium, rubidium, cesium. Like this you can understand. Okay, this is what atomic order size. Atomic size order. Okay, then next. So now what about the elements that are arranged like this? So now second period elements, if you take lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, if you consider like this. So atomic number like 3, 4, 5, 6, 7, 8, 9 like that you are writing now. So if you observe this electronic configuration, how can you write? This is 2s1, this is 2s1, 2s2, this is 2s2, 2p1, this is 2s2, 2p2, 2s2, 2p3, this is 2s2, 2p4, this is 2p5. So now what you are understanding, if you go across a period like left to right in the periodic table, the electron is entering into the same shell, same n value, same principal quantum number. But here if you observe principal quantum number, this shell number is getting increased in the groups, but in the period the electron is entering into the same shell number. So all that electrons, newly added electrons are entering into this shell number only now. Now what happens? These nuclear forces, these positive charges strongly attract the electrons. Okay, if they are strongly attracting the electrons, means what happens to the size? Size decreases. So left to right, what happens to the size? Left to right, atomic size. What happens? Atomic size decreases in the periodic table, So across a period, size decreases. Why? Because that newly added electron entering into the same energy levels. That's why size decreases. Remember up to here? Right. So nothing to by heart here, everything is to understand. Okay. So now tell me which is the least size here out of all these elements. So fluorine will be the least, like this you can write. And one more thing, sir, you are writing only from lithium to fluorine. Why not neon or noble gases? Because noble gases size is exceptionally high in any of the respective periods. The highest size is for noble gases. Okay, this is exceptionally thing to discuss. But up to from here to here, what you can say, from alkali metals to halogen, size decreases. Remember like that. So the smallest size here is fluorine, you can understand. Okay, remember. Right. The next thing is, so up to these elements it is fine, sir. Now what about this kind of ions? How can we answer? Yeah. So remember, there are two things. Let us say atom A is there, and this atom A only with a negative charge and atom A only with positive charge. So these positive and negative charges are called ions. Okay. So now look at this, what I am making. This is the nucleus. Yellow color one is nucleus, let us consider, and this red color line, circular paths, are considered as shell numbers, like shells or orbits in which electrons are lying. Okay, like this we have this much big atom size is there. So now what I am doing is, I am removing the electrons from here. If I remove electrons, what happens? It becomes less electrons. See, initially it has same number of protons, same number of electrons. Therefore size is something like this. But now what I am doing is, I am putting same number of protons, but some electrons are removed from here. If electrons are removed, the positive charges are more now. So when these positive charges are more, they will strongly attract the electrons, whatever the remaining electrons present here. Therefore what happens, if positive charge is strongly attracting towards itself, that electron cloud will be compacted and the size decreases. That's why always remember, cation size is smaller than the atom. Always remember, cation size is smaller than the atoms. Now what I am doing, the third case here we have is adding electrons. If we add electrons to atom, what happens? Add electrons to atom. Like from here to here you are adding electrons. Okay, from here to here you are removing electrons. If you are adding electrons, it becomes anion. Becoming anion means more number of electrons are present now. So if more number of electrons are present, that electron cloud is big, it becomes bigger now. If it is bigger means size also increases. So always remember, anion size is greater than atom, atom size is greater than positive charge. Okay, done. Next, and let us include here itself. So I am making only one electron addition, it becoming anion. Further one more electron, what happens? More electron density, more electron cloud means more bigger is the size. So always as negative charge on the atom increases, that size also increases. More negative charge on that particular species, more is the size, remember. Okay, now look at this. only one positive charge is there means I have just removed one electron. If I remove one more electron also, two electrons also, now what happens? The electron count is further decreasing and nuclear forces are further increasing. So more nuclear forces, more positive charge, smaller the size. Why smaller the size? So strongly that electrons are strongly attracted by the positive charges. Okay, right. So I can say more positive charge, smaller the size. Okay, like this you can arrange. Okay, now let us conclude this with one simple line or with one simple relation. See, atomic size or the size, simply you can say size is inversely proportional to nuclear charge. What do we mean by nuclear charge? This positive charge is there now, so that is called nuclear charge. More nuclear charge, more positive charge, smaller the size. So more nuclear charge, more positive charge, smaller is the size. Okay, so more positive charge, smaller the size. Okay, remember like that. And more negative charge, larger is the size. More negative charge, larger is the size. Remember like that. Okay, that's it. Up to here it is clear now, right? So can you make some questions here? Yeah. So I will be giving you some questions. You just answer me here. So carbon with -4 charge, with -4 charge. Carbon with -4 charge, carbon with -2 charge, carbon atom, carbon with +2 charge. Arrange these elements in the arrange this species in the increasing order of their sizes. Okay, so whatever the concept you understood, based on that you can tell me your answer. Okay, now look at the question that I have mentioned. So scandium, titanium, see titanium, what is the atomic number of titanium if I write? So titanium atomic number is 22, but what is the charge you are seeing here? +4 now. It means from this atom you remove 4 electron, therefore titanium becomes titanium +4. Okay, so from here how many electrons we removed? 4 electrons are removed, that's why +4 charge I am writing. సో అటామిక్ నెంబర్ అంటే నెంబర్ ఆఫ్ ప్రోటాన్స్ ఎన్ని ఉన్నాయి? 22 ఉన్నాయి. బట్ ఎలక్ట్రాన్స్ ఎన్ని ఉన్నాయి? ఇప్పుడు ఓన్లీ 18 ఉన్నాయి. బికాస్ ఫ్రమ్ దిస్ యాటమ్ వి రిమూవ్డ్ 4 ఎలక్ట్రాన్స్, దట్స్ వై ఇట్ ఈస్ బికమింగ్ +4 charge. Okay, manganese is there here. So manganese also, manganese atomic number is how much? 25 we have. Okay, so from manganese you are removing 7 electrons, therefore it is becoming Mn+7. Okay, so 27 from 27 electrons, 25 electrons you are removing 7. So now how many remaining elements we have? Here also 18 electrons we have. How many electrons? So these two species, whether the charges, whatever the charges you are seeing, the both of them are having same number of electrons. Malli okkar vinandi what I am saying. Atomic number 22 means it has 22 electrons, 22 protons. But titanium converting from 0 charge to +4 charge. How many electrons you removed? From these 22 electrons you removed 4 electrons. Remaining electrons are how many? 18 electrons are there. Okay, in titanium +4 how many electrons are there? 18 electrons. How many protons are there? Electrons are 18. How many protons are there? Protons remains same as its atomic number, that is 22 only. Okay, because we are not disturbing protons, we are just removing these outside electrons, that's why it is becoming +4 charge. Okay, nice. Next, look at this. Atomic number is 25 for the manganese. Now it is becoming +7. So 25 protons, 25 electrons are there in this manganese atom. Now you are making it as +7 means here you are removing 7 electrons out of this 25. If you are removing 7 electrons means it becomes how many electrons now? Atomic number will be same. Atomic number of protons will be 25 only, but electron count becomes 18. So only 18 electrons are there in the both species. See, same number of electrons now. If the two species are having same number of electrons, those are considered as isoelectronic species. What I am saying? Isoelectronic species. Once again, what do we mean by isoelectronic species? ఏదైనా 2 లేదా 3 ఆటమ్స్ అలా అయాన్స్ తీసుకుంటే అందులో కనుక సేమ్ ఎలక్ట్రాన్ కౌంట్ ఉందనుకోండి, అన్నిట్లలో కూడా సేమ్ ఎలక్ట్రాన్ కౌంటింగ్ అనేది ఉందనుకోండి, వీ కెన్ సే దెమ్ యాజ్ ఐసో ఎలక్ట్రానిక్ స్పీషీస్. ఇక్కడ ఇందులో కూడా 18 ఎలక్ట్రాన్స్, ఇందులో కూడా 18 ఎలక్ట్రాన్స్ ఉన్నాయి కదా, వాటిని మనం ఏమనాలి, ఐసో ఎలక్ట్రానిక్ స్పీషీస్ అనాలి. ఓకే, బట్ మోర్ పాజిటివ్ ఛార్జ్ ఎక్కడ ఉంది, మోర్ పాజిటివ్ ఛార్జ్ ఇన్ మ్యాంగనీస్ నా, సి మోర్ is a nuclear charge, smaller will be the size. So this is a not correct option, because what is the correct order about size they are asking now. So do you agree with this? No. Why? More nuclear charge, smaller is the size. So manganese should be smaller than the titanium plus 4, you should write here. Okay, right. The next one here, I am taking them here, positive, potassium plus chlorine with minus. So now tell me, what about these two things? Potassium atomic number is 19, but positive charge is there, means how many electrons we have? Only 18 electrons. Chlorine atomic number is 17, minus charge is there, means you are added 1 electron, it is also becoming 18 electrons. So same number of electrons now, you can say them as isoelectronic species. Okay, so in the isoelectronic species, what I told you, if same number of electrons, isoelectronic, that is fine. What I told you, more is a negative charge, greater the size. More is a positive charge, smaller the size. So more positive charge, small size, more negative charge, larger size. Okay, like this. That's it. This is the order of the size. Okay, right. So it means this option whatever we are seeing is this one. The third option whatever we are seeing is incorrect. Why it is incorrect? Because that chloride ion should be larger in size, not the potassium ion. Okay, next one, phosphorus is given with +3 charge, with +5 charge. Already I explained about this by taking A +3, A +5 example I have taken. So more positive charge, smaller size. This is more positive charge for the same element, smaller size. So this should be the answer. So as per our discussion, what is the best answer for the discussion here? Option 4. Sir, you haven't explained about option number 2. You explained all remaining options, not 2. So second option is also incorrect. Why incorrect? Means they have taken chlorine atoms, like chloride ions, but this is mentioned as 35, this is mentioned as 37. So what these numbers indicates here? Numbers indicates its mass number. So mass number are differ here because these are called isotopes. Isotopes are the species having same number of protons and electrons but different number of neutrons. What makes the difference? Different number of neutrons. So due to the difference in the neutron number, we are getting these isotopes. For two isotopes, size will be always same. So their sizes are same. Okay, and here negative charge is also equal now. So it means you should write it out like this, not as the one which they have mentioned. Okay, so that's why this option 2 also incorrect. So fourth option will be the perfect for the discussion. Okay, I hope everything that we discussed in the session is really helpful for you. If you like the content, please hit on the like button, and you can share with your friends who are moving from 10th class to 11th to 12th, whoever preparing for NEET, JEE, EAPCET exams. Okay, so thanks for watching, stay connected.